For page 32, we're going to be looking at operations on polynomials. We're going to add them, subtract them, multiply them, and divide them. And so for your foldable that kind of looks like a flower, you're going to cut it out, and then you'll fold it along the dotted edges, or the dotted lines. And so when you fold it, it's going to look something kind of like this. So each of these will open up, and inside each of the tabs we're going to have some information. And so for this first one, we're going to do f plus g of x, which is the same thing as f of x plus g of x. This next one will be f minus g of x, the one on the right, which will be the same thing as f of x minus g of x. It looks just like this tab, except the only difference is got this plus instead of, it's got a minus instead of a plus here. The one right here above is f times g parentheses of x, which is the same thing as f of x times g of x. And this last one is going to be f slash g with a parentheses around it and then of x, and then we've got f of x divided by g of x. So we'll open up each of these tabs individually. We'll start with the one with addition first. And so to add polynomials, well, before we do that, open them all up. And so when you're combining functions by addition, subtraction, multiplication, or division, it says the domain of the new function consists of those x and the domain of both f and g. So sometimes along the way you'll have to come up with a new domain as well. If you end up with something along the way when you're doing this and you have something else that you can't include, then you'll include that in the domain later and say that it's restricted as well. But I'll show you an example of that in just a minute. So in each of these tabs, regardless of which tab we do, add, subtract, multiply, or divide, our f of x will be x squared minus 9, and our g of x will be x plus 3 divided by x. So now when we open up the bottom tab for f plus g of x, we've got x squared minus 9 plus x plus 3 divided by x. In order to add these two, x squared minus 9 with this rational function here, we need to get a common denominator. So we've got x cubed divided by x minus 9x divided by x plus x plus 3 over x. This allows us to be able to add these now. And so when we do that, we get x cubed. This negative 9x plus positive x is going to be positive 8x. And then we've got our plus 3 at the top, all divided by x. And so the only domain restriction here we have is going to be that x is not allowed to be 3. When you open up the tab to the right of that, f minus g of x, we've got x squared minus 9 minus x plus 3 over x. So it's going to be very similar. The only difference is we're subtracting the two instead of adding them. So you'll notice that the first and second step are almost the exact same. Get a common denominator still. Now, however, instead of adding the two functions, we're going to subtract them. So we've got x cubed minus 9x minus x will become negative 10x. And then we've got that negative that distributes to that positive 3, which becomes minus 3, all divided by x. And same domain, x is not allowed to be equal to 3. When you open the tab at the top, we're multiplying the two functions, f times g of x. And so we've got x squared minus 9, and we're going to want to multiply that by x plus 3 divided by x. So when you're multiplying fractions, you just simply multiply straight across. We've got this x squared plus minus 9 is really over 1, even though we don't see it. So when we go to FOIL this out, we've got two binomials, x squared minus 9, and then x plus 3. So we'll FOIL this first, outer, inner, last. When you do that at the top, you get x cubed plus 3x squared minus 9x minus 27, all divided by x. And same thing, x is not allowed to be equal to 0. And finally, on the last tab, we've got f slash g in parentheses div of x, which is equal to, and then we've got f of x at the top here, x squared minus 9. We want to divide that by x plus 3 divided by x. You should remember from your Algebra 1 days that when you have a fraction within a fraction, you want to divide them, you're going to multiply by the reciprocal. Some Algebra 1 teachers call it keep, change, flip. You keep the numerator, change the division symbol to a multiplication, and flip the denominator. That's the same thing as multiplying by the reciprocal. So we've got x squared minus 9 times the reciprocal of the denominator is x divided by x plus 3. And so now you'll notice that x squared minus 9 times x would be at the top of the fraction, and then x plus 3 times 1 would be at the bottom of the fraction. Now, unfortunately, this is not simplified, so x squared minus 9 is a difference of squares, so you would factor that into x plus 3, x minus 3. You still have x at the top, and you still have x plus 3 at the bottom. Now we've got x plus 3 and x plus 3 are factors that can be canceled. So at the top, we just simply have x minus 3 times x, and then we'll distribute that to become x squared minus 3x. Now, from the original problem, g of x was not allowed to be equal to 0. But as I said, sometimes along the way, you end up with something else that's not allowed. So in this case, x plus 3 is also not allowed. So, I'm sorry, it's allowed, but we're not allowed to have 0 at the bottom. And x equals negative 3 is what would make this bottom 0. So therefore, we have to restrict x equals negative 3 as well. And then we need to go back to the front page here at the bottom. Well, it's still page 32, but I had it covered up earlier. So now I'm going to come here and looking at this graphically. So we've got a few function values that it's looking for, f plus g of 2, f minus g of negative 1, and so forth. And so in order to do this, you go to the graph. The red graph here is considered f of x, so these are all the y values f of x. Things like f of 1.5, f of 0.5, f of 0. We've got all kinds of y values that are highlighted here in red. And then g of x is going to be this blue, looks like part of an absolute value, and then a horizontal line here. And so these are going to be all the y values of g of x. So for example, g of positive 3, g of positive 1, g of negative 2, and so forth. So f plus g of 2 means take f of 2, which is 0 in this case. If you go to x equals 2, 1, 2, the y value is 0. And you're going to add that to g of positive 2. So that means I'm going to go to the blue one, 1, 2. The value of that is negative 1. When you add 0 plus negative 1, you get negative 1. We would continue to do the rest of these in the same way. F of 1 minus f of negative 1 minus g of negative 1 is going to be 3 minus negative 2. The two negatives cancel and become 3 plus 2, which is going to give you 5. G times f of 0, you'll find g of 0 will come here to x equals 0, that's 0. We'll go here to f of 0, which is 4, but 0 times 4 is 4. 0. 0 times 4 is 0, sorry about that. And then finally the last one, f divided by g of negative 2. F of negative 2, when we go there, is going to be 0. G of negative 2, when we come to the blue one, is going to be negative 4. So if you take 0 and divide it by negative 4, you still end up with 0. And then these last two, you can just scratch them out. We want this fifth one down is about compositions. We won't do that just yet. And this f plus g is a generic, no matter what f or g are, what would be the new graph of that. And we're not going to graph that. I'm not going to make you responsible for that. And that's it for page 32.